Okay, the fourth unit is two-dimensional elements. Two-dimensional elements. Now, in this two-dimensional elements, there are different types. Already we discussed in the first unit, that is triangular element. Might we know that triangular elements. Okay, so another one is rectangular element. Okay, these two elements we might be know that already we discussed different type of elements. Now in these elements, by using these elements, what we have to do is we need to get the solutions for the structural problems. Structural problems. Now, before going to solve or before going to get the solutions related to that structural problems, first of all we should know the how to use this element, means how to derive the element stiffness matrix. That thing we might be know that. And before that, first of all we should understand the how to derive the shape functions for this element. Okay, this element, another name it is called Cst element, means constant strain triangle elements. Okay, another element is LST, linear strain triangular elements. See, this is CST. LST means simple thing. In the CST, at the end of its points, three nodes are there. Okay, three nodes are there for a triangular element, that is the CST elements, constant strain triangle elements. LST means linear strain triangular elements. Linear strain triangular element means in between these nodal points, at the mid of its sides, there is some node points are there. Okay, this type of elements are called LST, linear strain triangle elements. Now we will discuss the derivation of shape functions for a two-dimensional problems. Now for this we use it to say that CST element, means because it is easy, constant, we can say that constant strain triangular elements. Okay, constant strain triangular element. Now first we need to understand its coordinates of the CST element. Now I am trying to draw the CST element placed in a space. Okay, CST element placed in a space means constant strain triangular element, this element. Okay, as usually this element has three nodes. We know that node 1, node 2, node 3. Now it is placed in the two-dimensional x and y coordinates space, in the space 2D space. Now first this elements has some coordinates. Yeah, it is placed node 1 at x1, y1. Second one is x2, y2. Third one is x3, y3. What are these? x1 and x2, y1 and y2. These are the coordinates of node 1, 2, 3, because it is placed in the space with three nodal points. That points coordinates, okay, that node points coordinates are x1, y1 at node 1, x2, y2 at node 2, x3, y3 at node 3. Now at the same time these components means at node 1 it may be a deflection of delta 1. I would like to change the color. Okay, suppose this one is delta 1 means displacement at node 1, and delta 2 displacement at node 3, and delta 3 node 3. What is this delta 1, 2, 3 displacements at node 1, 2, 3? Deltas are the displacements for understanding purpose. Displacements. So the displacement has some components, means the displacement is in one way. At each node it is a two-dimensional element. At the same time it is placed in the two-dimensional. So we can say that the components of the deltas means it has to resolve into x and y direction. This is u1, v1, u1 and v1. u1 and v1 are the components of delta in x and y direction. Okay. Similarly, because of this delta 2 displacement at node 2, what is there? u2, v2. Same way we can say that this is u3 and v3. Now we have an idea what are the coordinates and what are the displacement components. We have a clear idea. x1 and x2 are the coordinates placed in the space in two dimension, and u and v's are the displacement components along x and y directions. We have to remember these points. Okay. Now once we know this these notations and all, then we need to write the polynomial equations. Okay, we need to write the polynomial equations. That is, in the polynomial equations we can write it as u in xy direction. Just understanding purpose. U is the function of x and y. It is equal to a1 plus a2x plus a3y. This is equation number 1 or 2, you can say. Okay. Similarly, the v is the function of x and y, because u and v are the components along x and y axis. That's what v is equal to, what we can say, that a4 plus a5x plus a6y. This we can say that equation 2. In this equation, in the Cst element, we can say that because of the element, the Cst element, 3 nodes. That's what we assume up to the polynomial equation. We choose up to 3 constants. Here the what are the a1 and a2, a3, a4 and a5, a6? What are these? Can anyone say that? We know that already. We discussed some of these things.
Polynomial functions.
Yeah, polynomial functions, polynomial constants or coefficients. Polynomial function only. Polynomial function means the a1 plus a2x plus a3y. That is the function. But a1 and a2, a3, a4, a5, a6. These are the polynomial coefficients, or we can simply say that constants. Okay. Now,
Okay, sir.
then our aim is we need to develop the shape functions for this 3-noded triangular element, Cst element. Simply we can discuss the Cst element. Okay. And then for understanding purpose I am writing Cst elements. Constant, strain, triangular element. Now we know the polynomial equations, and we know its boundary conditions, nodal conditions, or simply you can say that nodal conditions. Why? Because each node has its own coordinates as well as displacement components. Okay. Now we need to identify them. So nodal conditions, we can write it as here, nodal conditions. Everyone has to note down whatever we are discussing. Try to practice. Okay. Nodal conditions. What are the nodal conditions? At node, there are 3 nodes. Now u is equal to u1 at node 1. Yes. V is equal to u1 simply, and v is equal to v1 only at x equal to x1 and y is equal to y1. At node 1, these are the conditions, nodal conditions. At node 1, just understanding purpose. And now second one, at node 2. At node 2, what is this? U is equal to u2 and v is equal to v2. And at x equal to x2 and y is equal to y at node 2. Now similarly at node 3, u is equal to u3 and v is equal to v3. At x equal to x3 and y is equal to y3. Okay, these are the nodal conditions. Nodal conditions. Now what we are concentrating is just we are bothering about only equation 1, because I will tell you, because in the equation 1 a1, a2, a3 are the constants. The same way an equation 2, this a4, a5, a6 are the same because of the same nodal conditions and same displacement components. Because of that reasons, you may have calculate the one means for one equations we may calculate it its shape functions, means a1 and a3, a1 and a2, a3 constants. Then from that we can calculate the shape functions. That shape functions directly we can use it in this equation. Okay, now our concentration is only equation 1. Okay, our concentration is equation 1. Now can I move? Make it fast because we have less time, then we have to make it fast somehow. So I can move. Now then we need to substitute these nodal conditions in equation 1. We need to substitute nodal conditions in equation 1. Now u, clearly write u1. Why? Because u at node 1, u is equal to u1, that is equal to a1 plus a2 x1 plus a3 y1. Okay, y1. At node 2, what is this? u2 is equal to a1 plus a2 x2 plus a3 y2. At node 3, u3 is equal to a1 plus a2 x3 plus a3 y3. So this is in equation 3, we can say that. Okay, because all are just we are substituting the nodal conditions and the equation 1 we will get. A similar way we can substitute the in equation 2 also, we will get the same way. That means v1 is equal to a4 plus a5 x1 plus a6 y1. No need to waste of our time, so we will get the same anyhow. So just what I am trying to do is, now I am writing this equations. These above 3 equations are there, equation 3. I am writing in matrix form. I am trying to writing in matrix form because it's for the simplifying purpose. So then u1, u2, u3 is vector, okay, is equal to 1 1 1 x1 y1 x2 y2 x3 y3. Okay, and then a1 a2 a3. The same is equation 3. This is same as whatever the equations are there, above equation. Just we are trying to rearrange it in matrix form. So what we need is, we need to calculate the a1 a2 a3, means we need to get the polynomial coefficients or constant. These things we need to calculate. So for that, just what we can say, that then just write as 1 1 1 x1 x2 x3 y1 y2 y3. This is inverse because we are just taking it to the other side. Okay, multiply with factor of u1 u2 u3. Okay, this is equation number 5. We can write. Now we need to inverse this equation. Equation inversion means we need to calculate the D inverse, means suppose we can say that C transpose by D. What is C? Cofactor matrix, and determine. D means determine. So we can write it like that. You might have an idea about that matrix operation. I think so. Yeah?
Hello?
Yes or no? Cofactor matrix determinant. The inverse is equal to cofactor matrix divided by determinant. We have an idea. No one is responding. No one responds. Mean what does it mean? Whether you know or not, I don't know that. First of all, these classes continue. It is okay. What's going on? What happened to you? So we need to just find out the cofactor matrix of this 3 by 3 and determinant of this 3 by 3. So for that we need to solve the cofactor under. Finally we can write it as, this one is a1 a2 a3 constants is equal to 1 by 2a, means area of the triangle. A means area of the triangle. Multiply with x2 y3 minus x3 y2. Okay, next one is x3 y1 minus x1 y3. The final one is x1 y2 minus x2 y1. And here is y2 minus y3. y3 minus y1, y1 minus y2, x3 minus x2, x1 minus x3, x2 minus x1. Okay, after transposing and finding its cofactors and all these things, finally we will get this matrix. Multiply with this is vector u1 u2 u3. Okay, this is our final matrix. Now then we can simplify this one. Means for simplicity of our mathematical equations, then we can rewrite this one is 1 by 2a multiply with alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3, multiply with u1, u2, u3. Okay, this is our final equation. Here what is alpha? Alpha 1 is equal to x2 minus y3 minus x3 minus y2. This is alpha 1. Alpha 2 x3 minus x3 y1 minus x1 y3. Alpha 3 is equal to x1 y2 minus x2 y1. These are the alpha 1 and 2. These are the, just we can say that if the matrix is there above matrix, the individual components alpha 1, beta 3. Similarly, in beta 1 is equal to y2 minus y3, beta 2 is equal to y3 minus y1, beta 3 is equal to y1 minus y2. Finally, this is gamma 1 is equal to x3 minus x2, gamma 2 is equal to x1 minus x3, gamma 3 is equal to x2 minus x1. Okay, these are the components of that matrix. Okay, now then we have an idea about the alpha, beta, gamma, its ones and twos. Okay, now we know the constant values. Then we need to substitute these constant values in equation 1. How we can substitute? We know the equation 1. What is the equation 1? U is equal to, what is that? A1 plus A2x plus A3y. Yeah, this one only, equation 1. Equation 1. Then what we have to do?
Sir.
Yeah, then we need to rearrange this equation. 1xy. Yeah. 1xy. Then this one is A1, A2, A3. Just simplifying. The equation is simplification. Just we know this A1 and A2 value, A3 values. Just now we calculated A1 and A2, A3 values. Just substitute this A1 and A2, A3 matrices in this equation 1. Then one I can write it as 1 x y. Okay, multiply with, what is this value? 1 by 2a multiply with alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3. Okay, these are the alpha, beta, gammas. Multiply with, what is this one is finally u1, u2, u3. This is the displacement vector in components in x direction. Now then we can multiply this equation, and multiplying 1 by 2a, then multiply with 1, row into column. You might be have an idea. Alpha 1, alpha 1 plus beta 1 x plus gamma 1 y. Yeah. Similarly, alpha 2 plus beta 2 x plus gamma 2 y. Last one is alpha 3 plus beta 3x plus gamma 3y, then multiply with u1, u2, u3. This is the displacement component. Okay, just what then for once again we can write it as alpha 1 plus beta 1x plus gamma 1y divided by 2a. Okay, this is the n1. Next element is alpha 2 beta 2x plus gamma 2y divided by 2a. And third one is alpha 3 beta 3x plus gamma 3y divided by 2a. Okay, multiply with u1 displacement vector, simply you can say. Okay, these are the components of that particular equation. You convert it into simply matrix form. Now, can I move? Are you listening? Are you following?
Yes, sir.
Okay. Then I will move on to the next one. Now then we can write it as simply u is equal to n1, n2, n3. What is this n1, n2, n3? u1, u2, u3. You can write it like this. Now what is n1 here? n1 means shape functions. That shape function is alpha 1 plus beta 1x plus gamma 1y divided by 2a, means area of that particular triangle. Now what is n2? Same way, alpha 2 plus beta 2x plus gamma 2y divided by 2a. Similarly n3, what is n3? Alpha 3 plus beta 3x plus gamma 3y divided by 2a. Here the n1, n2, n3 are the shape functions of this Cst elements. Okay, Cst element shape functions. Now we can write it as simply u is equal to finally n1 u1 plus n2 u2 plus n3 u3. Okay, this is final equation number whatever we have written in the previous slides. And then, equation numbers we forget, maybe it is 10 or 11. Okay, now this is the displacement equation in terms of its shape functions. Now these are the shape functions. n1 and n2, n3 are the shape functions. Here the alpha, beta, gamma in terms of. What is alpha 1? Alpha 1 x2 y3 minus x3 y2.
X3,
Yeah, that is the alpha 1. Yeah, that is the alpha 1. So we need to remember that alpha, beta, gammas because it is very simple, because it may following some like some rule, chain rule, because alpha 1 is there. Here the no x and y terms are 2, 3. Like that we need to remember. Okay, we will follow some rule. Now already we calculated what is that shape functions for the x components. Yeah, then we can write it as v is equal to Same way, we can write it as n1 v1 plus n2 v2 plus n3 v3. We can write it same way, because we may follow the same method, then we will get the same values. Then no need to do all these things. Okay. Now our displacement components, how we can represent u v, or we can put it as here x comma y. Y means u is the function of x and y, and v is also function of x and y. For your convenience, I am writing here. Okay. This is the displacement vector uv components is equal to how we can write it as n1 0 n2 0 n3 0. Similarly 0 n1 0 n2 0 n3 multiply with displacement vector u1 v1 u2 v2 u3 v3. Then you get an idea. Whatever the written this u and v equations, just we are simplifying, or in the matrix form we are trying to write here. Yeah, uv means the displacement components of uv at particular point is equal to n1 0 n2 0 n3 0 0 0 n1 0 n2 0 n3 multiply with its displacement vector. What is that? u1 v1 u2 v2 u3 v3. Okay, these are the displacements of this Cst element. Okay, Cst elements. Some of the others we might write it as delta. Already I told you, delta means at any point the delta displacement is equal to its shape functions multiply with its displacement components. For simplicity, they use it to write like this. At any point, displacement at any point, delta p means at any point, is equal to shape functions of the displacement, means this one only, n1 0 n2 0, that only, multiply with its displacement vector, means here the displacement vector is, that is u1 v1 u2 v2 u3 v3. Okay, now once we know this, means once we know the shape functions, then we can move on to the next steps.